At this point, we've made some great progress. We've created our repository, started doing some work, and have been committing our changes along the way. We're still missing a pretty important piece of this picture, though. How do we go back and review our commits now that they're in the repository? Git gives us access to this information with a few simple commands.
And we're back in our really cool project. If we look, we can see that all of the files we've been working on are still there. But now we're interested in what all of those commits look like. We can see the end product here, but we want to explore our history. The first command we can use for this is git log. As you might expect from the name, git log shows us a log of all of our commits. By default, this log starts with the most recent commits. You can see that down at the bottom of the list we have the earliest, added a README file. You can see that each log entry has a lot of information. It starts with a unique commit identifier, often called a hash. This is a special string of characters that is virtually guaranteed to be unique for that particular change, and it's how Git references different commits under the hood. The commit identifiers might seem needlessly complicated. After all, why can't we just use simple numbers? Our first commit could be commit 1, then commit 2, and so on. Well, this works for really simple projects, and it's actually how some other version control systems will operate. The issue with Git is that, because anyone could have a copy of the repository, it's not always easy to determine what order commits occurred in without having to change the numbers around later. This long string of characters is kind of ugly and unwieldy, but it will never have to change over the course of the project. Just underneath the commit identifier, you can see information about the author of the commit. You can see right when I realized that Treehouse user was wrong and started using my real name and email address. Then we have some information about the date and time that the code was committed. And finally, we see the commit message itself. This is why it's important to make good commit messages. If you're trying to find out when a bug was introduced into the system, for example, my change file 1 message doesn't tell you anything useful about what was done in the project. Now that we can view a listing of all of our commits, what if we want to look at the details of a specific commit? Let's say we wanted to know what the code looked like right after we added our new project files. We actually have a few different options. Our first option is to check a version out of the repository, much like you'd check a book out of the library. We know, thanks to git log, what the commit identifier is. All we have to do now is use the git checkout command and provide it with the commit identifier. We could copy and paste the whole commit identifier, or we could type it all out, but it's really long. Fortunately, Git doesn't need the whole thing. It just needs enough to know which commit you're talking about. Typically, you can get away with just using the first 5 or 6 characters. After we run the command, we see a really scary error message about something like a detached head state. This actually isn't a scary situation. This is just Git's way of letting you know that you've checked out an older version of your code, and that if you try to make any changes right now, things could get weird. To carry our library analogy a little further, think of it as the librarian warning you not to write in the book you just checked out. That's okay though. We're not looking to make any changes, we just want to have a look around. We can see that all of our files are here, so nothing looks different there. But remember that we made some changes to file 1 and file 2? Let's use the cat tool to see if those changes are still there. Nope, both files are empty, just like they were when we first committed them. We've essentially gone back in time to before we made our changes to file 1 and file 2. But now, how do we get back to a place where it's safe for us to work? You might think that we'd use the git checkout command again, and you'd be right, but where do we tell it to go? Remember that in our git status output it told us that we were on branch master? We'll talk more about branching soon, but for now, we know that we really want to get back to the latest changes we made while we were on branch master. We can do this by just telling Git that we want to check out master, and it will do the rest for us. Sure enough, if we run git log, we can see all of our more recent commits. And if we cat file 1 and file 2, All of our changes are there. The other option we have is to do what's called a diff of the changes between versions. A diff is a special type of output intended to show us what's changed, or, if you prefer, what's different, hence the name, between two versions of our project. Let's say we wanted to see what had changed between our added changes to file 1 commit and our added changes to file 2 commit. We'll just run a git diff with the commit identifier of the first commit and the commit identifier of the second commit. This output is kind of confusing by default, but if we skip some of the output at the top, we can see that our change, in this case adding, hence the plus sign, this is file 2 to the file, is listed as the only difference between the two commits. There are graphical interfaces and other tools you can use in order to view commits in a more friendly fashion, but this is the basic idea. You select two commits and get an output of what's changed between them.
Now you're starting to see the advantage of using Git. It's really convenient to browse through your project's history if you're good about making regular commits. At this point, we've been through most of the basic interactions in Git. Let's go through the whole process again, just to make sure we've got it down.